Hello everybody, welcome to the mathematics course for programming. In this video, we are going to discuss the use of combinatorics for computer programming. So what is combinatorics? It is really a branch of mathematics that is dealing with counting, arrangement, and combination of objects. It is widely used in programming for algorithm design, optimization, probability calculations, and data analysis. That means we want to do some counting before we can determine the probability or before we can optimize our algorithms. So we will cover a number of topics about combinatorics. The first topic to discuss is the counting principle and factorials. So what is the meaning of a counting principle? It is something like this one. It helps us to figure out how many different ways we can do something by multiplying the number of choices that you have for each of the steps. So for example, we have this situation here. We have m ways to do one thing and we have n ways to do another thing. And the total number of ways to do both things will be m times n. Okay, so that is the counting principle. M ways to do one thing and n ways to do another thing. To do both things, we have m times n ways. Okay, so if we have more steps to continue, we can just keep multiplying. So we can have m times n times p for different number of ways for different things. Okay, so let us see this example here. Suppose we are in an ice cream shop and we can choose the ice creams in different categories. So we have 6 flavors and 3 types of cones and 2 toppings. So how many different ice cream combos can we make? The answer is rather simple. We multiply 6, 3, and 2 together to get 36 as the answer. That means we can have 36 ways of choosing the flavors, the type of cones, and the toppings all together. Okay. So here we can produce 36 ways of creating our ice cream combos. Okay. And let us talk about another important concept called factorial. So the factorial of a non-negative number n is denoted by n followed by an exclamation mark. Okay, so this is called n factorial, and this n factorial is really the product of all the positive integers less than or equal to n. So the formula is like this. If we have an n here, we just do n times n minus 1 times n minus 2 until we reach 1. So we multiply all these numbers together. And how about 0 here? If n is equal to 0, which is allowed for a non-negative number here, 0 factorial will be 1 by definition. Okay, so we have to remember this definition explicitly in order to understand the way to find the factorial. Okay, so how can we apply the factorials and counting principle in programming? We can find out the core components in permutation and combination calculations. So the counting principle together with the factorial definition would help us evaluate the permutation and the combination calculations that will be discussed later. And if we know how to use the factorials and the counting principle, we can use them in recursive algorithms and dynamic programming. Of course, we can use the factorials and the counting principle in probability and statistical calculations. And we can also use them to generate sequences or trees. For example, the binary tree structures. Okay. So let us see how we can implement the counting principle and the permutation. So let us see here. So when we use Python to implement the factorial, we can just write a factorial function by using the recursion principle. So if n is equal to 0 or n equals to 1, then I would say that I have to return 1 according to the definition of a factorial. And if n is not 0 or 1, I can just do this one. N times factorial n minus 1. So it means that I can do recursion to get n times n minus 1 times n minus 2 up to multiply 1 further. Okay. So suppose we have n equals 5 here, you will expect that the factorial will just be 5 times factorial 4, and when it comes to factorial 4, it will be going back to the original definition here. So I will have 5 times 4 according to this n, and factorial 3, and then when you go further, you will have 5 times 4 times 3 times 2 times 1 as the answer, because when we go to n equals 1, we will return 1, and the previous multiplications of 2, 3, 4 up to n will be evaluated as well. So let us see the result. Okay, you will see 120 here. Okay, so it means that I'm doing 5 times 4 times 3 times 2 times 1, so that I'm able to get a factorial of 5. Okay. Now let's talk about another important concept about combinatorics called permutation. So what is a permutation? A permutation here is an arrangement of objects in a specific order, and the number of permutations of n distinct objects taken r at a time is called Pnr. Okay, n here is the number of distinct objects, which means that they are all distinguishable, and r here means that we take r objects at a time. Okay, r out of n. Okay, so what is a permutation? We can see an example here. Suppose you have 3 friends, Alex, Bella, and Charlie, and you want to line them up for a photo. So how many different ways can you arrange them? We can have actually 3 ways, by doing Alex first, followed by Bella, followed by Charlie. Or we can put Bella first, followed by Charlie, followed by Alex. And we can also do the other arrangement as Charlie first, followed by Alex, followed by Bella. So actually, these 3 ways are some of the possible ways of doing the permutation, so that the order would count. Okay, so each arrangement is a permutation because the order matters. Okay, the order is important. That means the first arrangement is not the same as the second arrangement, and it is not the same as the third arrangement. Okay, so actually we have a way to really calculate the number of permutations when we have n and r. We can use this formula here. Pnr equals n factorial divided by n minus r factorial. Okay, so n minus r factorial has to be calculated first before we do further. Okay, and let us see this example. Suppose we have 5 books, but we only want to arrange 3 of them on a shelf. That means we don't use all the books, but we just pick up 3 out of 5 books. Okay, so how many different permutations can we have? We can just apply this formula directly. 5 factorial divided by 5 minus 3 factorial. So it means that I will have 5 factorial divided by 2 factorial. Okay, and it is just equal to 5 times 4 times 3 times 2 factorial divided by 2 factorial. This means that I will have 60 different ways to put the books when the order is important. Okay, that is the answer, 60 different ways. Okay, on the other hand, if we want to arrange all the 5 books on the shelf, the number of permutations is just this one, 5 factorial divided by 5 minus 5 factorial, which means that it is 5 factorial divided by 0 factorial, which is just equal to 120. So if we put all the books onto the shelf, there are 120 different ways of putting them when we consider different orders. Okay, so how can we apply permutations in programming? We have such examples here. We can generate all the possible arrangements in string permutations and in task scheduling. We can also use permutations to solve the problems like the traveling salesman problem, TSP. And we can also use permutation in cryptography. For example, when we want to generate unique keys, we can use permutations to help us do so. And we can also use permutations in algorithm design for backtracking or brute force solutions. That means we can find out all the possible ways of backtracking required and all the possible ways of doing the brute force calculations. And let us see how we can implement permutations in Python. So here I have used the iter2s module, and from the module I have the permutations feature to help me do the permutations directly. So how can we do so? I want to show the permutations of ABC by joining all the 3 letters together. So I can use this function called getPermutations, and I'm going to put a string as the parameter. And if I have put the string into the function, I want to do the permutations function by putting the s into it. And then this permutations function is able to pick up different letters in different orders. And after joining the result coming from permutations without any symbol in between two results, I'm able to show all the possible permutations. So let us see the result here. Yes, you can see A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. So you can see that the permutations function here can obtain A, B, and C in the permuted order. And when I join the letters without any letter in between two permuted letters, I'm able to show all these 6 possibilities. Okay. So that is the meaning of permutation. And I can use the feature in Python to help us do the permutations easily. Okay, the third part to discuss in combinatorics is called combinations. A combination is a bit different from permutations. A combination is a selection of objects without regard to order. That means the order is not important in this case. And the number of ways to choose R objects from n distinct objects is called CNR. Okay, so we have the number of distinct objects and the number of things to pick up. And now we don't care about the order. So imagine you are picking 2 drinks from a menu of 4 drinks: juice, soda, tea, and water. If we choose just juice and soda, it is the same as choosing soda and juice, because the order doesn't really count in this situation. So we have a combination of juice and soda, or soda and juice. They are the same thing, okay? So if we want to do the combination, we can have another formula like this one. N factorial divided by the whole thing here. R factorial times n minus r factorial. Okay. So let us see this example now. Suppose we have 5 pizza toppings and we want to pick up 3 out of 5 for my pizza. Okay. The order isn't really important in this case. That's why I can use combinations to see the number of possible ways to put the toppings. Okay. So I can just apply the formula here as 5 factorial divided by 3 factorial times 5 minus 3 factorial. That means I have 5 factorial divided by 3 factorial times 2 factorial. If we do some simplification, we will have 10 as the answer. That means we have 10 different ways of putting 3 toppings out of 5 on my pizza. Okay. And remember that the order doesn't really matter in this case when we use the combination. Okay. So how can we apply combinations in programming? We can use it to select subsets. For example, when we want to form a team, or when we want to find out the features that are selected in machine learning, we can use combinations because the order to handle the team formation or the feature selection doesn't always matter. Okay. And we can also use combinations in graph algorithms. For example, when we want to find out the clicks or independent sets. Okay. And we can also use combinations to do probability calculations. For example, when we want to consider the poker hand probabilities, we will use combinations because the order of the cards doesn't really matter. And we can also use combinations to generate test cases or configurations. So let us see how we can implement combinations in Python. So we can also use the feature from iter2's module, and this feature is called combinations. And I can just pick up an array here. This array will be passed to this function, and I also need to show the number of elements that will be picked up in each combination. So I have a length of 4 here, and r is 2. So n is 4 and r is 2. So according to the formula, we will have 6 combinations. That means we will have 6 different ways of arranging these numbers. So I can just use combinations function, and when I put the array and r here, I can just list out all the possible combinations. So let us see the result. So you can see now that I have 6 combinations according to the combination formula, okay? And we have 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. And when we talk about combinations, the order doesn't matter. So 1, 2 is just the same as 2, 1. 1, 3 is just the same as 3, 1. That's why I don't need to put so many new combinations in my answer. Okay, so here the list command here is going to put all the results in the list. And the other thing to talk about for combinatorics is the inclusion-exclusion principle. So this principle is able to calculate the size of the union of multiple set by accounting for overlaps. That is a bit abstract. I'm going to use an example to tell you the meaning here. So you can ask your classmates who likes pizza, we have 15 people, and who likes burger, we have 10 people. But we also have 5 people who like both. So if we just add 15 and 10 here, we will be double counting the 5 people who like both, okay? In this situation, we have some overlap between the set of people who like pizza and the set of people who like burgers. So in this situation, how about just subtracting the repeated part from the 2 sets here? So it means that I will just have 20 people altogether, okay? So that is the correct number of students who like pizza or burgers, okay? And for the 20 people here, 5 of them like both, and 15 of them like only one of them, okay? So if we have 3 groups instead of 2 groups, how can we handle the overlap? We can use a formula to do so. A union B union C here is meaning the combined sets of the 3 groups, okay? And the vertical lines here would represent the number of elements, okay? So the number of elements on the left hand side is equal to the sum and difference of the number of elements in different sets, okay? So the number of things in set A plus the number of things in set B plus the number of things in set C minus the number of things in the intersection A and B minus the number of things in the intersection A and C minus the number of things in the intersection B and C plus the number of things in the intersection A and B and C, okay? So that is the meaning from the Venn diagram here. So for the total number of people in the 3 sets, we can use this diagram to help us understand the calculation. So we add all the content in the individual sets. So the first set is A, so I have to include 1, 4, 5, and 7. And for set B, I have to include all the 4 parts. So 2, 4, 6, and 7 will be included in set B. Similarly, for set C, we have to include 3, 5, 6, and 7 together. Okay, so we add all the numbers represented by these regions. So you will see that some regions are overlapping. Okay, so we need to subtract the overlapping regions in 2 groups. So for set A and set B, the overlapping area will be 4 and 7. That's why I have to subtract 4, 7 here. And for set A and set C, the overlapping area will be 5 and 7. That's why I have to remove the portion 5 and 7 here. And for set B and set C, the overlapping region will be 6 and 7. That's why I have to remove this part as well. Okay. And you can see that I have removed 7 for too many times. That's why I have to add back the overlap of all the 3 parts. That's why I have to include 7 here. So when we check the formula here together with the Venn diagram here, you will see that I'm able to match the result for each of the number of elements here. Okay, so this is for A, this is for B, this is for C, and then I do the subtraction of the number of elements in the overlapping region of set A and set B, and in the overlapping region of set A and set C, and in the overlapping region of set B and set C. and then I add up the middle part, which is the intersection of both A, B, and C, okay? So let us see an example. Suppose I have 30 students in art club, 25 students in music club, and 20 students in drama club. And some of the students are in more than one club. For example, 10 people are in both art and music club. 8 people are in both art and drama club. 5 people are in both music and drama club. And 3 of the students are in all 3 clubs. So we want to find out the number of students who are in at least one club. That means I want to see how many students join one of these 3 clubs. So by using the inclusion-exclusion principle here, I can just apply this formula. So you can see that I'm able to plug in the numbers directly into the equation, and then I will see 55 as the answer. That means I will have 55 students who are at least in one of the 3 clubs, okay? So some of them can join more than one, or some of them can join only one, and some of them can just join all the 3 clubs actually. So how can we apply the inclusion-exclusion principle in programming? We can use it in the counting problems with overlapping conditions. For example, the number of elements satisfying both or 3 or 4 properties. Okay. And we can use the inclusion-exclusion principle in the probability calculations like the event probabilities. And we can also use it in data query optimization. For example, we need to count the number of distinct records in our database. And we can also use the inclusion-exclusion principle in graph theory. For example, if we want to do the counting of the paths or cycles, we can just use this property to get the net number of paths without overlapping. Okay, so we can see that the implementation of the inclusion-exclusion principle here is rather complicated. But in Python, if we want to answer this question here, we can have a simpler way. So let us see how we can implement the inclusion-exclusion principle in a direct way. The way is rather easy. So suppose I want to see how many numbers from 1 to 100 would be divisible by 2, 3, or 5. So that is the question here. I want to see how many number of values from 1 to 100 will be divisible by 2, 3, or 5. So if a number is 6, 6 is already divisible by 2. So I won't need to go through here, because when I use the OR command here, when one of the conditions is satisfied, we will not go further. That's why we will not do double counting when we use the OR logic to link the 3 possible cases here, okay? So if I find such a number that is divisible by 2, 3, or 5, I add 1 here. So the sum here is going to see how many ones are there for this condition to hold, okay? If this condition holds, I add 1. So you will see how many numbers that will be divisible by 2, 3, or 5. So let me run the program. So we have 74 numbers from 1 to 100 that is divisible by 2, 3, or 5. So in these 74 numbers here, some of them will be divisible by both 2, 3, or 5. For example, 30, 60, and 90. So these 3 numbers will be divisible by both 2, 3, or 5, but they won't be counted more than once, okay? Because when we have 30 here, it is already satisfying this condition. That means these 2 conditions will not be checked further for 30, 60, and 90. That means these 3 numbers will not be counted more than once, okay? So this video has discussed some topics about combinatorics. We know the counting principle now and the factorial definition here. Also, we know how to do permutations by using the formula here. The permutation has a property that we have to count the order, okay? And for combinations, it is the opposite of permutations. We don't need to count the order. Okay, when we have 2 things combined already, we don't care about the order. So juice and soda will be the same as soda and juice here. Okay. And for the inclusion-exclusion principle here, we just need to use it to find the number of values that can satisfy at least one of the conditions by using this formula. And we can visualize the inclusion-exclusion principle by using a Venn diagram. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.